Okay, good evening, guys. How are you? Okay, so today I want us to go through some questions on sketching trig functions. Okay, some of you were inboxing me. You are saying we need to do questions on this. Okay, so that's why I've brought it here so that we can handle it. Okay, so that we can handle it. So we are going to do questions on sketching trig functions. Okay, I'm surprised why you're just the two of you in class. Okay, so the first thing to do when you're given a trig function is to interpret the reaction that you've been given. Okay, you interpret the equation that you've been given. And then from the equation, you come up with the period, then you come up with the amplitude, and then you come up with your phase shift. Okay, then after coming up with all that, that's when now you can sketch your graph. Okay, so move like that. So this is our question here. Let me get a pen. Yeah, so this here is our question. Okay, so they are saying what? They are saying state the period, the amplitude, and the phase shift for the graph of the equation. Okay, so they have given us the equation here. Fx is equals to 1 minus 2 cos x plus pi over 3. Okay, then they're saying sketch the graph. Okay, so I said when you are sketching graphs for trigonometric functions, okay, you first have to find all these individual things they have mentioned here. Okay, period, amplitude, phase shift. Okay, and you also have to find a vertical shift. Okay, I don't know why they didn't include it here. You also have to find the vertical shift. Okay, vertical shift. Okay, so vertical shift is the shift in the y-axis. Okay, in the y-axis. Then the phase shift is the shift in the x-axis. Okay, the amplitude is just how far the graph will go, either up or down. Okay, then the period is the extent to which the graph will go in the x-axis. Okay, so we are solving this. I didn't put a board here. Okay, just a minute. Okay, so we are solving this question here. So what do we have there? We have the function f of x is equals to 1 minus 2 cos x plus pi over 3. Okay, so this is our function. Then we say the first thing is to find the period. Okay, so how do you find the period? The period is simply 2 pi, okay, over b. Okay, 2 pi over b, that's the formula, where b there is just the coefficient of x. Okay, b is the coefficient of x. So we can see that in this equation, the coefficient of x there is just 1. Okay, the coefficient of x there is just 1, meaning this period of ours will just be 2 pi over 1. Okay, and this will definitely give us 2 pi there. Okay, so this is the period. After finding the period, now you find your amplitude. Okay, you find your amplitude. And how do you find your amplitude? You simply get the coefficient of the trigonometric ratio, okay, or the trigonometric function, meaning we have to get the coefficient of cos. Okay, so you get the coefficient of cos or sine. Okay, depending on what you've been given here, you always get the coefficient of the trig function here. When it's cos, you get the coefficient there. When it's sine, you also get the coefficient there. Meaning here, our amplitude is just what? It's just -2 there. Okay, our amplitude is just -2 there. Okay, then you put this in moduluses. Okay, because the amplitude doesn't have to have a sign. Okay, why? Because you can go either direction. You can go up and you can go down. Okay, by that magnitude. Okay, no wonder we are finding the modulus of this, meaning here the amplitude is just what? 2. Okay, the amplitude is just 2. Okay, then after that, let's find now the phase shift. Okay, phase shift. So how do you find the phase shift? Okay, how do you find the phase shift? You equate whatever is in the brackets there. Okay, whatever is paired with the x here. Okay, you equate it to 0 and solve for x. That's how you find the phase shift. So there you have x plus pi over 3 is equals to 0. Okay, so let's find our phase shift. Our phase shift will just simply be x is equals to the negative of 3. Okay, so this is our phase shift, meaning what? It means, okay, it means from our original range, okay, from our original range on the x-axis, we're going to shift to the left by pi over 3. Okay, that's what the phase shift means. Okay, so after getting the phase shift, which is the same as the horizontal shift, now we can get our vertical shift. Okay, vertical shift. Vertical shift here. Okay, so how do you get your vertical shift? Okay, how do you get your vertical shift? You just look at a number that is not together with this trig ratio. Okay, so you can see that starting from -2 cos x plus pi over 3 there, all this is together, but this one here is just alone. Okay, so whatever is alone, this one can also be this side. I can say +1 here. Okay, so this is the vertical shift. So the vertical shift we put here that it's 1. Okay, vertical shift it's 1. And since it's positive, it means the shift is shifting up. Okay, it means the graph is shifting up because this guy here, the vertical shift, is positive. If we had a negative vertical shift, it means the shift would have gone down. But here it's positive, so meaning the shift will go up like that. Okay, so now after finding your period, you found the amplitude, the phase shift, which is also known as the horizontal shift, and the vertical shift. Okay, after you found that, now you have to find your original range. Okay, your original range. Then you have to find the shifted range. Okay, then after that you find your original height. Okay, then again you shift that height. Okay, so how are we going to do that? Okay, how are we going to do that? Okay, so we look at the period because the period shows us the range in the x-axis like that. Okay, so here if the period is 2 pi, it means this graph should start from 0 all the way to 2 pi. Okay, this graph should start from 0 all the way to 2 pi. Okay, but we have a phase shift. Okay, so I said negative, meaning this graph is going to be shifted to the left, this side, okay, by these units. So we have to find the new range. Okay, so the range there will be, Okay, so original range there will be from 0 to 2 pi. Okay, that will be our original range. And then when we include the phase shift, okay, when you include the phase shift, it means this range is going to shift to the left, okay, shifting to the left there by pi over 3, okay, meaning here you add the minus pi over 3, okay, here you add it, the minus pi over 3, and again you add it here, the minus pi over 3. So 0 plus minus pi over 3, it means the new range here when you apply the phase shift, okay, so here I'll write new range. When you apply the phase shift, the new range will just start from minus pi over 3, okay, then here you say 2 pi plus minus pi over 3, okay, so 2 pi minus pi over 3, what is it going to give you? Okay, so it's going to give you 3, then here on top you have your 5 pi like that. Okay, so it means our graph will start from minus pi over 3 all the way to 5 pi over what? 3. Okay, so I hope you are following. Okay, if you have any question, just unmute yourself and ask. Okay, unmute yourself and ask. Okay, so now this is the range.
Yeah, I'm lost.
Okay, where are you lost? Hello? Hello? Where are you lost? Oh, okay, she'll ask when she comes back. I don't know what has happened to her. Okay, so now after finding the new range here, okay, from the original range that we got because we knew our period, okay, so this will be the x-axis, okay. Let's now find the range in the y and its new range when it's shifted, okay. So the original range in the y, we follow the amplitude, okay. If the original range in the x, we followed what? This phase, we followed the period and the phase shift. Then original range in the y, we are going to follow the amplitude and the vertical shift, okay? So the original range there, since the amplitude is 2, it means supposed to start from 0 all the way up to 2, okay? From 0, what am I saying? Not 0, here I meant from -2 all the way up to 2, okay? So the original range here will be from -2 all the way to 2, okay? Then when you apply the vertical shift here, okay? Vertical shift, then you have your new range there, okay? Vertical shift, you have your new range there. It means the new range there will add 1 here and 1 there. Why? Because that's the vertical shift, okay? So you can see here, the vertical shift is 1. So we are going to add 1 to this. We're just going to get -1. And then we're going to add 1 to this. We are going to get what? +3. Okay, so this is the new range in the y, okay? And this is the new range in the x. So we are going to use now the new range and the new range in the x and the new range in the y to plot the graph, okay? To plot the graph. Okay, someone saying she's not understanding on how to find the ranges. Okay, so I'll upload this video. I think I'll upload it after the class so you can watch it because I'm working with time. Okay, I'm working with time, but I'll try to explain a bit here. So pay attention. I said when you are given a function, you first find the period. How do you find the period? You use 2 pi over b, where b is the coefficient of x. And the coefficient of x here, we said it was 1. Okay, so 1 divided into that, we found our period as this. Okay, the next thing is to find the amplitude. The amplitude is just the modulus of the coefficient of either cos or sine. We saw here that the coefficient was -2. Find the modulus of that. we find that it's 2, okay? Then after finding the amplitude, we said we find the phase shift. How do you find the phase shift? We equate whatever is paired with the x in the brackets here to 0, okay? And then you solve for x. That's how we ended up with minus pi over 3, okay? Then after the phase shift, you find the vertical shift. How do you find the vertical shift? The vertical shift, you just get the lonely number here, that is single, okay? We said it was 1 and it's positive, meaning this shift is going up, okay? Then now on the ranges, we said the original range, you get it from the period that you're going to find here, okay? So here we can see that our period was 2 pi, meaning our range there starts from 0 all the way up to 2 pi, okay? So now how do we get the new range? We add the phase shift to either this and that, okay? So that's what we did here. We added this guy there, and again, we added that guy there. We got the new range here in the x-axis. Then in the y, the original range, you get it from the amplitude, okay? So the amplitude is 2, meaning it's going to start from -2 all the way up to +2. Then how do you get the new range? You apply the vertical shift, okay? The vertical shift is just 1 here. So you add 1 on both this and this side, okay? So if I add 1 here, I'm going to have a -1, and I add 1 here, I'm going to have a +3, okay? So that's the summary. Then now let's plot, okay? I'm sure we have all understood now. Let's plot. So how do you plot? You draw your x or y plane, okay? So this is my y, and then let me draw my x like that, okay? This is my x, and then this is my y, okay? So you can now label them, okay? So we know that this is 0, you can put 1, you can put 2 there, and you can put 3, okay? Even down there, we do the same. This will be -1, -2 there, then you have -3 there, okay? Then in the x-axis, you have to include the angles, okay? So the original shift had 0 all the way up to 2 pi, okay? If you remember, okay? Then we said this range is shifted to the left by -pi/3, okay? Meaning from this 0 here, if the graph was supposed to start from 0, it has shifted to the left by minus, okay? It has shifted to the left by -pi/3, okay? And if it was supposed to end at 2 pi, it has shifted to the left, and it's now at what? 5pi/3, okay? 5pi/3, okay? So meaning our graph will just start here, okay? Let me, okay, just this, we'll start from here, okay, all the way up to here. It means that's where our graph will be, okay? Then let's get a different color to plot the graph. Okay, so we plot the graph in relation to the ranges that we have in the x and the ranges that we have in the y, okay? So we said starting from -pi/3, ending at pi5/3, okay? Ending at pi5/3, okay? So we can now sketch our graph. We can now sketch our graph. Okay, so before we sketch, we have to find the midpoint between -pi/3 and 5pi/3, okay? So if you add, you have to add this, you add to that, then you divide by 2, you are going to find 2 pi, okay? You're going to find 2 pi there over 3, okay? You're going to find 2 pi/3, then you can show it like that, okay? So the graph is not up to scale. You can see that this space is smaller than this, but we are taking this as the middle. And how are we finding the middle? We are just adding this to that, then you divide by 2, okay? So you're going to find the middle value here. Okay, so now before you graph, you have to know this. Okay, so if you have a course and you are graphing it, okay, if you have a course and you are graphing it, it means, okay, it means the graph will be somewhere like that. Okay, so you have your last point there and your last point there. No, you have your last point here, okay, and your last point there. Then your middle value will be there, okay. So it will have this shape if it's cos. Then if it's sine, okay, if it's sine, it means it's going to go like that, okay, going to go like that. You have your first point there and your last point there with the middle point there, okay. So there on our graph, we have the last point, we have the starting point, and we have the middle value, okay. So which means we can just draw a graph there, okay. So here, this is what I was saying. We have the starting point is this, okay. Then the end point is this, and this is our value, okay. And we said, how is the graph for sine? For cos, it's just like that, okay. So here now you come and plot that graph, okay. So using this range, okay, using this range, you can see that you have a -1 and 3, meaning when you go up, your graph should end at what? Should end at 3, okay. Then when you go down, your graph should end at -1, okay. So you apply this at the last minute, or at the last step, I mean. Okay, you apply this at the last step. Okay, so we are going to start with that, okay. So we'll use first our original range that we had in the y, okay, to plot this, okay. So we can see that it's starting from 2 all the way up to -2, okay. 2 all the way up to -2 there, okay. So it means the graph will start from there, okay. It will start from there, it will pass what am I doing? Okay, I was saying the graph will start from 2 there, then it will drop there, okay. Make sure it reaches 2 here, and then it comes back up again, and it reaches 2, okay. So this is the first sketch, okay. I should have drawn this in dotted lines. Okay, so I'm saying it's going to be like that. Okay. It's going to be like that. Okay, just a minute. Okay, sorry for that, guys. My dad called. Okay, so I was saying you draw the sketch, okay? You first draw the first sketch here, okay? So this is the first sketch, okay? Then after you draw your first sketch, okay? After you draw your first sketch, you go back to the equation and I forgot to mention at first, okay? You go back to this equation and look at the sign that is there, okay? So if you have a minus there, it means when you draw a positive graph like this, okay, because of this minus, this graph will shift and will start facing down, okay? Facing down the opposite values that you had here, okay? So here we had +2 on that, then here it was -2. So we shift it, okay? So here it becomes our -2, they are positive 2. Okay, so that's what we are going to do here. We are going to reflect this graph in the x-axis. Okay, so meaning here, if it started at 2, here it's going to start at what? We're going to start at negative 2. Okay, so it will come like that. Okay, so this is our second stage. Then it will reach at 2 and it will turn and it will go like that. Okay. Then after the second sketch now, then you have to apply the vertical shift here. We said the vertical shift is just shifting this graph up by the number of units that it has. Okay. So the vertical shift was 1. So we are shifting this graph by 1 up. Okay. Meaning if you have a point at negative 2, it's going now to be at minus 1. Okay, let me use I think which color? Okay, even brown. Okay, so if I had a point at minus 2, this point will shift up by 1 and it will become a minus 1 there. Okay, become a minus 1. Then if I had a point here at minus 1, it will shift and it will go at 0. Okay, just like that. If I had a point on 2 here, to shift and it will become 3. Okay, then again you look at your value here. Okay, this value is 0. This value is 0. It means it's going to shift from 0 there, going to shift up by 1. Okay, like that. Then this value here is what? It's minus 2. It's going to shift and it's going to become minus 1 there somewhere. Okay, meaning what was on minus 1 is now at 0. Okay, then now you draw a solid line through those points like that. Okay, draw like that. I missed this point here. Draw like that. Okay, so you have a point there. You can see a point there, a point there, a point there, and a point there. Okay, then you label this as your graph of what? 1 minus 2 cos what was in the bracket? X plus pi over 3. Yeah, I think it was this. Okay, so do you have any questions on this, guys? Hello? Do you have any questions on this, guys? We can proceed. Hello? I can see 3 people in class. Please, I need your feedback. Can we proceed?
We can proceed.
Okay. So, okay, that's how you solve that one. Okay, so if you didn't understand this, then you are going to understand on the next one. So we are going to solve a similar question. Okay. So we are going to solve a similar question here. Where is it? This one here down. Okay, so this is a similar question here. They're saying let f be the function f of x is equals to 2 minus 3 cos 2x. Okay, 3 cos 2x. So we said the first thing there is to find the what? The period, you find the amplitude, you find the phase shift, and then you find your vertical shift. Then you can sketch. Okay, then you can sketch. So that is question 4C that we are doing. Okay, so let's find the period. Okay, so the period for this, okay, so we are dealing with this question. Okay, so what function do we have here? Oh, this was the last question. We have f of x is equal to 2 minus 3 cos x. Okay, so f of x is equals to 2 minus 3 was 2x. Okay, so that's the question there. Yes, this one. So how do we do this? We said we find the period first. Okay, so the period we said is 2 pi over b. Okay, 2 pi over b, and we said our b is just the coefficient of x. Okay, so the coefficient of x there, you can see that it's what? 2. So divide by 2, what are you going to have? We're just going to have your pi, meaning our original range will start from 0 all the way up to what? Pi. Okay, then let's find our amplitude. So our amplitude, okay, our amplitude is equals to the coefficient of either cos or sine. Okay, so the modulus of the coefficient of cos, which is just 3, okay, it will give me 3. Okay, meaning up there the limit is 3, and then down there the limit is -3. Okay, so this is your original range in the y. Okay, and then this is for x, like that. Okay, then after that you're going to find your phase shift. Okay, and we said phase shift is just to get anything that is paired with x, then you equate it to 0. So here you can see that you have 2x. Okay, so 2x, you're going to equate it to what? To 0. Then meaning here when you find x, x is going to be 0. Okay, so this is x is equals to 0. Then after that, you are going to find the vertical shift. Okay, vertical shift, we said you just get the number that is low here. Okay, sometimes they write it plus this side or minus this side. Okay, so the 2 there is the vertical shift, and it's saying it's going up. Okay, it's going up. Okay, then after that now, okay, we found our period there. Okay, we found our period, our amplitude, our phase shift, and our vertical shift. Okay, so this phase shift here is also known as the horizontal shift. Okay, so from here now we are going to find the original range. Okay, so this will be in the x. Okay, so original range will be equals to, we already saw it here, it is from 0 to pi. Okay, so from 0 all the way up to pi, 0 all the way up to pi. Okay, then the new range after applying, because we are in the x-axis, after applying the phase shift is going to be, okay, so you can see that the phase shift here was just 0, so meaning 0 plus 0 is going to give you what? 0. Okay, comma 0 plus pi is still going to give you what? Pi. Okay, so in this question there was no phase shift because the phase shift there was just 0. Okay, then in the y now, let's find our ranges. So original range in the y is equals to, okay, we said since the amplitude is 3, it means the original range will start from -3 all the way up to 3. Okay, so it means you have a -3 there all the way up to 3, like that. Okay, then from there now you find the new range after applying the vertical shift. Okay, and we said the vertical shift there, it's what number? It's just 2 going up, meaning we are going to add 2 to this and 2 to that. When you add 2 to this, just going to give you -1. Then when you add 2 to that, it's going to give you what? 5. Okay, it's going to give you 5. Then after this now, you can draw your graph. Okay, so if we draw a graph like that, okay, and that, okay, so this will be our 0. We said this, the original range is 0 to pi, not 2 pi. Why am I writing 2 there?